All right, so for our last topic for um, this course, we're going to talk about spectrophotometry. Okay, so spectrophotometry is a method of analysis that we still use today inside the clinical laboratory, but in our practice, we use a more advanced version of spectrophotometry in which it's a bit automated. So semi-automated as they call it. So as opposed to what you will see inside the learning laboratory in which it is manually operated to its extent. Anyways, we're going to talk about parts, functions, and principles. So, spectrophotometry versus photometry. Now, when you use a spectrophotometer or when you say spectrophotometer, it measures light at set wavelengths. Now, this is very important because we consider wavelengths in spectrophotometry, and it uses gratings or prisms. It's a type of monochromator, which we're going to be talking about later. But anyways, as opposed to your photometry, which uses light without consideration for wavelength. So basically, when you talk about photometry, you're simply measuring light without consideration for wavelength. By the way, if you're not yet familiar, let's try to review the concept of wavelength. Now, when you say wavelength, it's a value at which the waves of certain light or certain light particles or waves can be measured at. So for a simpler explanation, when you say wavelength in our purpose, we're actually referring to the color of light. Okay? So in photometry, instead of using a grating, which can select your wavelength, we use filters, which basically isolates broad wavelengths. No? So when you use gratings, you can select a much smaller range of wavelength as opposed to your filters which can only isolate a broad wavelength. Okay, so moving on. This is what I was referring to earlier as wavelengths. So wavelengths are measured in nanometers, shortened to nm. And then here is the region we can see. This is called the visible light region. As you can see, it ranges from purple to red. Okay, so red is the greatest or the largest or the longest in terms of wavelength. And your visible light is, or rather your purple or your violet is the shortest. Now, as the wavelength becomes larger or longer, as the wavelength increases, we can observe that energy decreases. So despite red or the color red being the longest visible wavelength, it is also the weakest. As opposed to your purple, which is the shortest wavelength in the visible light region, this one is the strongest. Strongest and weakest in terms of energy transmitted. Okay, so that is the reason why ultraviolet, which is just below the visible light region, hindi natin nakikita yung ultraviolet because, again, we don't have receptors in our eyes to look for or to see ultraviolet. This is, in fact, one of the harmful rays that comes from the sun. That's the reason why when you go to the beach, you get sunburn. So these are because of the ultraviolet light. Now, infrared naman is a shorter or rather a longer wavelength, but it's also weak. That's why it's safe to use inside the house. It's safe to use in remote controls. It's safe to use in other technology in your cell phones and so on and so forth. Okay, so another interesting fact that you have to learn is that years ago there was a misconception or there was news about radio waves being harmful to us, no? So they call it, technically it is radiation, but it is what you call non-ionizing and low energy. Okay, so low energy na siya. Ano ba yung myth natin dito dati? Sabi nila, if you sleep with your cell phone beside your head, nakaka-apekto daw yun sa utak, can cause cancer, and so on and so forth. So these are in fact not accurate. Bakit? Because radio waves are non-ionizing and low energy. So mahaba yung wavelength niya, but it's also low energy. So it does not affect our sleep, it does not affect our cells, it does not affect our bodies. Okay, so be careful of what you read on the internet and be careful of what you believe in. Okay, no? So as opposed to your ultraviolet, which again can cause sunburn, and then your X-rays, which is used primarily for diagnostic purposes, specifically X-rays, no, yung mga skeletal studies natin. But as you know, X-rays are very limited per person. So binibilang lang ng mga medical professionals and radio technologists kung ilang beses pwedeng magpa-X-ray ang isang tao. Okay? And then you have gamma rays, which are emitted from radioactive material, and of course, cosmic rays, which can kill you about in an instant kapag na-expose kayo dito without personal protection. Okay? So again, as the wavelength or the wavelength decreases, the energy increases. As the wavelength naman increases, the energy naman decreases. Okay? So be mindful of that concept. Okay, so principle of light, no? We perceive color as the part of light that bounces off the object. So in this case, in this field, this is color black, or rather a kind of grayish or dark gray. You perceive dark gray because those wavelengths of light bounce off the screen or is projected by the screen into your eyes. So the opposite of dark gray is the one that is being absorbed by the material. Okay, that is the concept of transmittance and absorbance. Later on, we're going to talk more about this. Therefore, the color of an object is not the color that it absorbs, but what it reflects. Okay, tulad ng sabi ko kanina, in this case, this field is a sort of a tortoise or turquoise green. But you're going to notice that that green is being perceived or nakikita natin yung kulay na green na yon kasi yun yung tumatalbog or yun yung nanggagaling sa screen na pumupunta sa mata natin. But technically, the color of that part of the screen, which is green, is the color that is not green. Okay, so I hope you understand the concept. No? And it also has light, has also duality. It can be particle, it can be considered a particle or as a wave, depending on what the nature is, if we're observing it or not. Anyways, excuse me. These are physics so we no longer need to dabble here because we're going to be talking about the analytic capabilities of the spectrophotometer. But it's also important for you to understand the concept. Okay, so analytical methods, we have spectrometry, which includes spectrophotometry, atomic absorption, and mass spectrometry. You also have luminescence, fluorescence, chemiluminescence, and nephelometry. We also have electroanalytic methods and chromatography. Alright, so spectrophotometry can measure emitted light, transmitted light, absorbed, scattered, and reflected. Kapag sinabi nating emitted, it's from the material itself. For example, this blue liquid, siya yung naglalabas ng light. This is what you call an emission. So para kung yung sa tambutso ng kotse natin, ang tawag doon ay emissions. Carbon emissions to be specific. Naglalabas yung kotse natin ng carbon. In this case, spectrophotometry can measure emitted light. It can also measure transmitted light, as shown in this example. So transmitted light is what you call the light that can pass through or that is left behind when it passes through an object. So basically, kung gaano kadaming ilaw yung lumalampas dun sa object, yung hindi nahaharang ng object natin. In this case, mapapansin nyo, this is a dark red and this is a lighter red. No? Bakit? Kasi yung material natin in between has absorbed some of the red and then nag-transmit na lang siya or nakatransmit na lang a lower amount of the light. Okay? It can also measure the absorbed light, which means ito yung na-absorb niya. This is your transmitted. This is your emitted. Okay, para lang clear tayo. And then it can also absorb or it can also measure scattered light. Scattered light naman, yung madedeflect niya or marerefract niya into different directions. Okay, so scattered. And also, it can also measure reflected light. So basically, all types of light, no, pwede niyang i-measure. So when you say reflected, uh, we're going to transmit light going to the sample, and then the sample is going to reflect the light. Okay? Spectrophotometry can also measure, again, reflected light. Okay, so colorimetry considers the following: the quality of color and the intensity of color. So just for your information, spectrophotometry is a type of colorimetry. So basically, we're measuring color, no? We're measuring color from the visible region, sometimes infrared, sometimes ultraviolet. So basically, we're trying to measure the intensity of color. Now, kinds of colorimetry, we have visual, which uses the eyes. Kung nagawa nyo na po yung Benedict's test, tsaka yung ano natin, yung mga color changing reactions natin, those are types of visual colorimetry. Now, under photoelectric colorimetry, which uses basically a photodetector and electricity, of course, kaya siya photoelectric, is spectrophotometry and filter photometry. Now, as we review natin kanina ang sabi natin, ang difference ni spectrophotometry and ng photometry is the type of light that it can measure. So, spectrophotometry, specific wavelengths. Si photometry, broad wavelengths. Okay? Next are types of electromagnetic energy. Now, we're not going to discuss this anymore kasi these are very physics. So, analytical chemistry tayo. But anyways, what we're concerned about is the visible ray region, ultraviolet, and infrared. Because spectrophotometry can dabble in these or can revolve around these range. So, radio, TV, and microwave, hindi na siya kasama because we no longer have, or rather, we don't usually use it for measurement. Okay, so again, another visualization of the spectrum. Excuse me. Next is Beer-Lambert's law. Beer-Lambert's law is the law of physics that basically makes the spectrophotometer work. No? So it states that the concentration of a substance is directly proportional to the amount of the light absorbed or inversely proportional to the logarithm of transmitted light. So ang sabi nila, yung amount of substance daw ay directly correlated dun sa light na na-absorb niya. So amount of substance equals absorb. Okay? So, ibig sabihin, the more light is absorbed, the more substance is present. Diba? So, paano ba natin i-visualize to? For example, you're trying to brew up coffee. Diba? The more coffee you put, the darker it gets. The less light can pass through your cup of coffee. Pero kung konti lang yung kape natin, let's say katiting lang, just the tip of the teaspoon, kapag minix mo siya, it's still going to be clear. So when you shine a light through that glass, a lot of light is still going to escape. And then the more you add coffee, the more you add the substance, mas magiging dark yung solution mo, and therefore hindi na makakadaan yung light. Kapag hindi na nakadaan yung light, it means that the light is being absorbed by the substance. Okay? Now, this can be only followed when the incident radiation on the substance of interest is monochromatic. This is very important. That's the reason why spectrophotometry is also used in measurement or in analytical purposes. It's because it can produce monochromatic light. Next, the solvent absorption is insignificant compared with the solute absorbance. The solute concentration is within given limits. Hindi pwede tayong sumobra sa solutes natin. And then, an optical interferent is not present, such as yung mga fingerprints natin. Okay, it's an optical interferent. Next, a chemical reaction does not occur between the molecule of interest and another solute or solvent molecule. So, ibig sabihin lang nito, yung last statement natin, that the solution that is trying to be measured or being measured should be done reacting. It should be stable. Okay? Next is transmittance. Ratio of the radiant energy transmitted divided by the radiant energy incident on the sample. So let's try to visualize that. No? For example, this is your analyte of choice. This is your incident light. Tinatawag natin siyang incident light because it's the first interaction of the sample with your light. And then this one is called your transmitted light. Bakit? Siya na yung nakatransmit to the sample. So, paano daw natin i-measure si percent transmittance? Sabi dito, yung incident light natin, we're going to use it to divide our transmitted light. So, basically, itong T over I, in this case, times 100%. Okay, so that is your transmittance. Okay, so again, this is a visualization of what we perceive as color. But anyways, let's sorry, excuse me. Let's try to discuss absorbance. Now, the amount of light that is absorbed, obviously, kaya nga siya absorbance, it is proportional to the inverse log of transmittance, and mathematically, it is derived from percent transmittance. So, ito yung formula niya. 2 minus the logarithm of percent transmittance, or absorbance is equal to negative log or logarithm of percent transmittance is equal to 1 over log percent transmittance. Okay, we're not going to be computing for that. You're going to be doing that in your clinical chemistry. But for now, be familiar with the concept of absorbance and transmittance. Okay, we can also measure absorbance through molar absorptivity. Again, you're going to be learning more about this in your clinical chemistry. Length of light through the solution or the light path. Okay, molar absorptivity, by the way, is given. Yung length of light path natin is the length of your sample container, and then the concentration of the absorbing molecules inside the solution. Okay, so this is your B. And again, your molar absorptivity is given. Okay, now moving on to the device itself, let's try to discuss the basic components of a spectrophotometer. You have your light source, very important. You have a device to isolate the light of a desired wavelength. Now, so kanina nabanggit na natin yung dalawa. We've mentioned gratings and filters. And then we also have prisms, by the way, para po ma-familiarize na rin kayo. You also have your cuvette, which is your sample container, your photodetector, which detects your readout, and your readout device, which communicates the information from the machine to the personnel, and then you have your data system. Okay, so isa-isahin natin siya. Now, light source, as the name suggests, is a source of light, no? Source of visible or non-visible light that may pass through the monochromator. The light of a proper wavelength will be made incident on the analytical set. So kapag sinabi natin, this is pure light, no? Pumupunta siya or na-generate siya ng light source natin without discrimination. It means the whole visible spectrum or UV or infrared kasama siya. Now, sabi dito, dadaan daw siya sa monochromator, which in fact, siya yung mag-isolate ng wavelength na kailangan natin. Okay, so this is a common tungsten halogen lamp. No need to study kasi hindi naman natin field yan. We have types of light source then. You have your continuum source, which emits radiation that changes in intensity. And you have your line source, which emits limited radiation and wavelength and uses an intense beam of light directed to the monochromator and the sample. Okay, usually line source naman yung ginagamit natin. Okay, so types of light source, you have your tungsten light bulb, which is the most commonly used light source. You have your laser, or light amplification by stimulated emission of radiation. And then, you also have your factors for choosing a light source, which is basically the range. Kung gusto mo ba na visible spectrum lang siya, or abot na yung UV and infrared, it's your choice. Spectral distribution, again, source, and then yung stability niya. Okay, so tungsten iodine lamp again is a common lamp used in spectrophotometry. You also have your quartz halide lamp, which contains small amounts of halogens such as iodine to prevent the decomposition of the vaporized tungsten from the very hot filament. You also have your DDL or deuterium discharge lamp, which provides energy source with high output in the UV range. So si DDL or deuterium discharge lamp, UV, siya. And then you have your infrared energy source, which can be a immersed glower or a glow bar. Ay nagkakaiba lang sila dun sa filament na ginagamit nila. Okay, so kapag tinanong ano yung sa visible, you can answer tungsten iodide lamp. Kapag tinanong naman ano yung sa UV, deuterium discharge lamp. And then kapag tinanong kung ano yung infrared, immersed glower or glow bar. Another one is your mercury vapor lamp, which exits narrow bands of energy at well-defined places in the spectrum, so UV and visible. You also have your hollow cathode lamp, which consists of a gas-tight chamber containing anode, a cylindrical cathode, and an inert gas such as helium or argon, or argon. Okay, so this is usually si hollow cathode lamp, ginagamit siya for atomic absorption spectrometry. Okay? Kapag tinanong kung ano yung UV invisible, mercury vapor lamp tayo. Next is laser. Properties of laser, it has spatial coherence. That's the reason why ginagamit siya sa mga nightclubs. No? It's a light show. So when you shine a laser, kung mapapansin nyo, it does not illuminate the surroundings very much. Kasi nga meron siyang spatial coherence. If a laser is fired from here to, to this point, it's going to draw a straight line. It's not going to spread out like your common light sources. Unlike your flashlight, na kapag gumamit ka ng flashlight from this source, malaki yung range niya talaga. Okay? It also produces monochromatic light. That's the reason why we have blue lasers, green lasers, because it does not require a monochromator. And next, lasers have pulse widths. Okay? Examples are given below. Okay, next part of the spectrophotometer is the entrance slit. The entrance slit minimizes unwanted or stray light and prevents the entrance of scattered light into the monochromator system. So from the light source, mag-shine siya ng light, meron tayong entrance slit dito. So meron tayong small window dyan. Now, the job of the entrance slit is to prevent outside sources from entering the monochromator. Ito yung monochromator natin. Okay? Hinaharang niyo yung light or yung contamination light or yung mga pollution light or yung mga noises from entering our monochromator. So, sinisigurado niya na yung light na tatama dun sa monochromator natin is solely from our light source. Okay? Kapag may stray light tayo, it causes systematic error. Nagkakos siya ng loss of linearity. That's the reason why spectrophotometers have lids. And it's very important that those lids stay closed. Okay, so as mentioned before, monochromator's job is to isolate specific wavelengths of light. Okay, so this is how it isolates your wavelength. So you have your light source, and ito yung tinatawag natin na entrance slit, or dito entrance aperture siya. But then, papasok yung light natin dyan, it's going to be reflected, and then yung glazed grating natin, isa-separate niya yung light natin. By the way, this is a type of grating lang. Kanina nabanggit na natin si grating. Okay, so it's going to reflect light, which is separated na into wavelengths. That's the reason why kapag nag-shine ka ng light somewhere that is grated, yung ganyan yung itsura, serrated, it's going to reflect into a rainbow. Okay, and then the parabolic mirror too, it's going to reflect the light further, and then it's going to isolate one specific wavelength. In this case, ang nakuha niya na wavelength ay color green. Okay? Next, we have filters. Glass filters have a wide band pass, And then you have your narrow band pass, which uses dielectric material of controlled thickness between two thinly silvered pieces of glass. Types of monochromator, you have colored filters. So think of a cellophane. If you want to shine a certain color of light, maglalagay ka ng plastic cellophane doon sa harap ng flashlight mo, and then for example, green yung cellophane mo, it's going to excuse me, shine a green light, no? You also have your interference filter, which utilizes the wave character of light to enhance the intensity of the desired wavelength by constructive interference and eliminate others by destructive interference and reflections. So, interference filter, basically yung wavelength na ganyan, it's going to enhance the desired wavelength and it's going to cancel out the undesired wavelengths. So, tinatanggal niya yung undesired wavelengths para makuha natin yung desired natin na wavelength. Okay? Another form of monochromator is a prism. So, wedge-shaped pieces of glass, quartz, sodium chloride, which is salt, or some other material that allows transmission of light. Very familiar naman kayo dito because this is a common experiment nung tayo ay grade school pa lang, no? You're going to get a prism, which is made of glass, tapos magsashine sila ng flashlight to the prism. And then it's going to produce a rainbow. Next, yung gratings natin, which are the monochromators that are most commonly used in our spectrophotometers nowadays, because mas madali siyang gamitin and mas convenient, mas maganda pati yung isolation niya ng light. So gratings has small grooves that cut uh, such angle that each groove behave like a very small prism. So these are considered to be multiple prisms. No? These are based on the principle that wavelengths are bent as they pass a sharp corner. You also have your modern holographic gratings, which are made using laser accurately scanned over a photosensitive material termed as photoresist. So these are extremely accurate. You have low light scatter. Ginagamit natin siya sa UV vis and IR spectrophotometers and high performance liquid chromatography, concave holographic reflective gratings. Okay, types of gratings. You have your transmission grating, which is a flat surface grating where lines are engraved on the surface of a mirror's polished metal slab, glass plate with thin metallic film. Ang example ng transmission grating ay yung Ekelens. So gratings ruled at a specific angle so that the maximum fraction of the radiant energy is directly transmitted and diffracted at a selected angle. Advantages of using gratings over prisms. And like I mentioned earlier, it's a lot better. Our gratings are a lot better than prisms. Kasi yung mga prisms natin, it's a bit primitive. Okay? Now, the exit slit controls the width of the light beam, which is termed as the bandpass. Okay, so, for example, ito yung light source. May entrance slit tayo dyan. Meron tayong monochromator. Anong trabaho ni entrance slit? To remove outside light from reaching the monochromator. Sa exit slit naman, it's there to make sure na yung isolated wavelength natin ay nasa tamang intensity. Okay? Or otherwise known as your bandpass. Next is your analytical cell or cuvette. So it is used to hold the solution in the instrument whose concentration is to be measured. Pwede siyang gawa sa glass, sa quartz, or sa plastic. What you're going to encounter most commonly is made of hard plastic, no? But it's optically clear naman. But again, plastics can degrade quickly. So madaling magasgasan yung surface niya. So as opposed to glass, which is harder than plastic, mas matagal yung lifespan, but mas mahal pati. Okay, so in analytical laboratories, what you're going to encounter is plastic, most commonly, or glass test tubes. Si quartz, kadalasan ginagamit lang siya for research because it's much more clearer than the other two. Okay, so types of cuvettes, you have your borosilicate glass cuvette for solutions that do not etch glass. Excuse me. You have your quartz or plastic, which does not absorb UV radiation at wavelength below 320. Now, si quartz or plastic, it's ideal for, as mentioned in this statement, it's ideal for UV. And then aluminosilica glass naman is good for visible. Excuse me. Cleaning agents for cuvette, you can use tap water or distilled water, mild detergent. It can be also soaked in a mixture of concentrated hydrochloric acid, water, and methanol at a ratio of 1:4. Next, cuvettes should never be soaked in dichromate solution. It can absorb and discolor the glass. Okay, so as much as possible, we want the glass and the cuvette to remain clear. So ayaw nating ma-discolor yung glass. Next, we have our photodetectors. Si photodetectors natin, this is an electron tube amplifying a current that can convert transmitted energy into an equivalent amount of electrical or photoelectric energy. So, anong nakikita nyo kaya dito, class? Or what do you think is happening in the ano? What do you think is happening in the picture? No, so at first glance, it's going to look like it's amplifying your wavelength. No? So after the light exits the cuvette or dumaan na siya sa cuvette, it's going to be a very minute amount of light. Sobrang liit niya. So the job of our photomultiplier tube, as this is to amplify that light so that madedetect natin siya. You have your barrier layer cells, which is composed of a film of light-sensitive material like selenium or iron plate with transparent layer of silver. It requires no external voltage sources. Next, you have your photoemissive tube or phototube, which has photosensitive materials that gives off electrons when light energy strikes it. Now, ito naman, kailangan niya ng outside voltage for operation. Next, our more common type of photodetector is yung photomultiplier tube. So it uses a series of electrodes to internally amplify the photo signal before leaving the tube. So ito yung nakita natin kanina na ina-amplify yung light na pumasok. And then you have also your meter, which is the simplest method of displaying output of the detection system. Also called the readout device, galvanometer, or ammeter. Now, for quality control, gumagamit tayo ng didymium and holmium oxide filter, which is used to check for wavelength accuracy. And you have your neutral density filters and dichromate solution, which verifies the absorbance, accuracy, and linearity. Okay, so that's the end of our final term. Again, this spectrophotometer is going to be studied more in your clinical chemistry, but hopefully this offers a bit of introduction para pagdating dun sa clinical chemistry, hindi na kayo masyadong mabigla. Okay, you're going to study more light sources, you're going to study more photodetectors, monochromators, you're going to study more different types of spectrophotometers. So, but this time, general lang muna tayo. Okay? So, thank you so much for listening and I hope you learned something new.